So I think we have done this, right? Now one thing you can understand from this is, to implement the single line of code, I have used 4 instructions, right? 4 instructions. Now every line of high level code will be implemented in assembly code using one or more number of instructions. Okay, it is very important point, please note down this. Every line of high level code will be implemented using one or more number of instructions in assembly code. Here it took 4 instructions. Sometimes it can take 5 instructions. Sometimes it can take only 1 instruction. Okay, it depends on the line of code we are saying. Fine. Now, what do we mean by machine code? Okay, what do we mean by machine code? See, machine code is the exact representation of this assembly code. Okay, only the way in which they look will be different, which means for this instruction I will be having an instruction over here. Okay, instruction over here. So let me erase this. For this instruction I will be having an instruction over here, and it will be a string of ones and zeros. Okay, something like 1 0 1 1 0 1 0, something like that. Okay, you can write something like this. Similarly, for this instruction I will be having a binary string 0 1 0 1 0 1 0. Okay, similarly for this instruction we will be having a binary string. For this instruction we will be having a binary string. Okay, now these are not just random numbers I have written. Okay, our computers will follow a system using which it will convert this instruction into a binary string with ones and zeros. Now once see, our CPU will be executing these instructions. Our CPU does not understand whether assembly code or a high level code. Okay, what our CPU will do is, it will fetch the machine code instruction by instruction and then it will execute it, which means it will take this instruction and then it will execute it. It will take this instruction and then it will execute it. Likewise, it will keep executing all the instructions. Okay, this is what we mean by instruction cycle. Okay, instruction cycle, which we will see it a bit later. Okay, we have a separate topic for instruction cycle. Now whenever CPU fetches this instruction, see, what do we mean by fetching this instruction? Obviously this instruction will be present in RAM, right? It will be present in RAM. Now whenever I use the term fetching, I mean that the instruction will be taken from RAM and it will be placed in the register. Okay, we have a special register called instruction register where this instruction will be placed. Okay, which we will see about them a bit later. Okay, but understand that this instruction will be taken by the CPU and then it will be executed. Now what do you mean by executing an instruction? If I execute this instruction, the action specified by this instruction will be performed, which means the value of A will be placed in register R1 once I complete the execution of this instruction. See, both are exactly same, only the language is different. Our computers don't understand this language, so we have converted into this language. But the idea is same, right? Idea is same. Now I think you got the difference between assembly code and machine code. For every instruction in assembly code, we will be having an instruction in machine code, but this instruction will be a string of ones and zeros. Okay, so that our computers can understand, or our CPU can understand. Fine. Now, why do we need 3 types of programs? Why can't we have a single program? Right? You might get a doubt. See, these programs are very easy for programmers to build a software. Right? See, if you take any software today, you can take something like Microsoft Word, Excel, PowerPoint, or Photoshop, or whatever software you take, we are building it using a high level code. Okay? Why? Because it is very easy to build a software using high level code. Instead of writing the single line, I am writing 4 lines here, right? 4 instructions, which is little bit irritating, right? I don't want to write lots of lines of program. I can easily implement this simple operation using the single line of code. So we build softwares using high level code. Most of the application developers build softwares using high level code. Obviously, if we want, we can still build softwares using assembly code and machine code. That is definitely possible. Okay, but we are not doing it today, just for simplicity. Okay, just for simplicity we are using high level code. Most of them use high level code. Obviously some advanced programmers, in order to implement a specific logic, they also program using assembly code. Okay, but nobody is programming today with machine code. Fine. Now we use high level code because it is very easy for programmers to code in order to build a software. Okay, now why do we need this machine code? Obviously our computers can only understand ones and zeros. It cannot understand our English words. So we are having this machine code. Okay, now why do we need this assembly code? See, we want to understand how a CPU will be fetching an instruction and then it will be executing it, right? Our CPU will always be fetching instructions one by one and then it will be executing it. It will not fetch this line of code and then it will execute it. It will fetch an instruction by instruction. It will fetch this instruction, execute it, fetch this instruction, execute it, fetch this instruction, execute it, right? Now, I need to understand exactly how this process is happening, right? So that I will analyze it and I will make it, I will follow some algorithms using which this execution will become much faster. Okay, we will do all these things in pipelining. There is a concept called pipelining where we will be making the running of these instructions much faster using a simple technique. Okay, we will see that a bit later, but understand that our CPU will be fetching instructions one by one. Now, in case if I look at this code, obviously I cannot understand exactly how CPU is fetching instructions and executing it because this program doesn't even have instructions, right? This is a collection of lines of code, right? This is a collection of instructions and we are more interested in instructions because our CPU fetches instructions and then it executes it, right? Also, see, you might say that we can definitely have this code instead of this code. We don't even need this code because here we are having instructions, right? Which means I can understand how CPU executes instructions using this code. I don't even need this code. But the problem here is we are not comfortable in understanding ones and zeros. It is very, very difficult, right? So that's the reason we have the concept of assembly code. Okay, assembly code, which means assembly code is human readable. This is not human readable, this is human readable. So this is human readable, fine. And also it is going to have instructions, right? It is going to have instructions so that we can easily understand how our CPU is actually fetching these instructions and executing it. Okay, so this is human readable, also it is going to have instructions, whereas this is not going to have instructions but it is human readable, right? Whereas here it is not human readable, but it is holding instructions. Okay, just for that reason we are having this assembly code. Okay, it will help us in understanding exactly how our CPU will be fetching instruction and then it will be executing it. Okay, also it is human readable. We can definitely understand exactly what's happening with this instruction, right? There we can definitely understand that. The only problem is it is very difficult to write these many lines of code in order to implement a simple logic, which we can do that using high level code. Okay, that's the reason we have something called as assembly code. I think you got a complete picture of why we have three types of programs. Fine. Now how this entire process will happen? Okay, let me give you a summary. Initially, we will be building softwares or we will be building products using something called as high level code, right? Now what will happen is our compiler or let me make it more simpler. Okay, let me make it more simpler. Our high level code will be given to a software called as compiler. Okay, compiler. Now what this compiler will do is it will convert it into something called as assembly code. Okay, we say it as assembly code. Now this assembly code will be given to something called as assembler. Okay, this is also a software just like compiler. We say it as assembler. Now what this assembler software will do is it will convert this assembly code into something called as machine code. Okay, this is machine code. See, machine code or .exe code, executable code, all these mean one and the same. Okay, machine code. Machine code. In some textbooks, instead of saying this, which means compiler converts high level code into assembly code and assembler converts assembly code into machine code, instead of saying this, some textbooks simply write it as our compiler converts high level code into machine code. Okay, some textbooks are writing it in a simpler way just like this. Compiler converts high level code into machine code. See, actually both are correct. Okay, both are correct. The reason is these days both this assembler software and compiler software are implemented using a single software and we say it as compiler. Okay, if you take few years back, this is how we were having two softwares, compiler and assembler. right, in order to perform this conversion. Now what has happened is both these softwares are implemented using a single software, and we together call it as compiler, which converts this high level code into machine code. How will it do this? It converts first high level code into assembly code and then assembly code to machine code. Okay, so both the definitions are correct. Some textbooks follow this definition, some textbooks follow this definition. Okay, I think you got the difference between both these definitions. So once we write the software, our compiler will convert the high level code into machine code, and this machine code will be placed in the hard disk of the computer, right? And now depending on how CPU requests for a byte, obviously the machine code will be placed in the RAM. Okay, and whenever we are executing these instructions, obviously the instructions will be moved from RAM to registers. Okay, all these things we have already seen it, right? Anyway, we will see more about this in detail.